Ever wonder why quantum mechanics is often called the physics of the very small? This intriguing science delves into the realm tinier than even an atom, where classical physics rules take a back seat. Here, particles can exist in multiple places at once, and their properties only become definite when measured. Quantum mechanics, in essence, is the study of this bizarre behavior, a universe that behaves unlike anything we see in our macroscopic world. Prepare to dive into a world smaller than you can possibly imagine. In the quantum world, particles can do a magic trick called quantum leap. Now, what does this mean? Well, imagine a particle like an electron moving from one energy level to another. In our everyday experience, we'd expect it to travel the distance between these 2 points, right? But here's where quantum mechanics flips everything on its head. These particles seem to teleport, skipping the space in between completely. This is what we call a quantum leap. Now, you might be wondering, how is this possible? And you wouldn't be alone. Even the greatest minds in physics have been puzzled by this peculiarity. The quantum leap defies our traditional understanding of how things should behave. It's like being in New York one moment and then finding yourself in Paris the next, without any memory of the flight. It's a jarring concept, isn't it? In fact, the term quantum leap is a bit of a misnomer. It suggests a big dramatic jump, but that's not quite accurate. In reality, quantum leaps often involve tiny changes in energy levels. But despite their small scale, these leaps are crucial. They are the very essence of what makes quantum mechanics different from classical physics. The idea of the quantum leap also challenges our conventional notions of reality. It suggests that the world at the smallest scales doesn't follow the same rules as the world we can see and touch. This is one of the reasons why quantum mechanics is often described as weird or spooky. But it's this very weirdness that makes it so fascinating. So next time you hear about a quantum leap, remember it's not about huge jumps or dramatic changes. It's about the tiny, almost magical shifts in energy that happen in the world of the very small. It's about particles that can be here one moment and there the next without moving through the space in between. In the quantum realm, teleportation isn't just a sci-fi concept. Did you know that in quantum mechanics, a cat can be both dead and alive at the same time? Welcome to the weird and wonderful world of superposition, a key principle in quantum mechanics. This concept can be a bit challenging to wrap our heads around as it defies our everyday experiences. Let's unpack this using the famous thought experiment proposed by physicist Erwin Schrödinger, featuring a hypothetical cat. Imagine a cat placed in a sealed box with a radioactive atom that has a 50% chance of decaying within an hour. If the atom decays, a poison is released, killing the cat. If the atom doesn't decay, the cat remains alive. In the world as we know it, the cat is either dead or alive, right? But here's where quantum mechanics throws a curveball. Until we open the box to check, the cat is in a state of superposition, meaning it's both dead and alive simultaneously. Sounds strange, doesn't it? This is because in quantum mechanics, particles exist in all potential states at once, only settling into one state when observed or measured. It's like flipping a coin. It's in a state of superposition, being both heads and tails, until it lands and is observed. This paradoxical concept is a cornerstone of quantum mechanics. It's what allows quantum computers to perform multiple calculations at once, increasing their processing power exponentially. But don't worry, this doesn't apply to our everyday lives, or does it? After all, we're made up of these very quantum particles. So next time you're pondering if you should have pizza or pasta for dinner, remember, in the quantum world, you could be eating both at the same time. And there you have it, the mind-bending principle of superposition, demonstrating that in the realm of the very small, things aren't always as they seem. Quantum mechanics allows for possibilities that challenge our everyday experiences. So, are you ready to dive deeper into this quantum quandary? Imagine being able to affect a particle miles away instantaneously. Welcome to quantum entanglement. This intriguing concept is one of the cornerstones of quantum physics, and it challenges our everyday perception of the natural world. So, what is quantum entanglement? Think of it like this. Take 2 particles and entangle them. Now, no matter how far apart they are, whether they're in the same room or on opposite sides of the universe, the state of one particle will instantly affect the state of the other. Change the spin of one, and the spin of its partner will change too, instantly, as if they shared an invisible, instantaneous connection. This was a concept so strange, so counterintuitive, that even the great Albert Einstein had a hard time accepting it. He famously referred to it as spooky action at a distance. But why did he find it so unsettling? Well, because it seemed to defy one of the most fundamental principles of physics, that nothing can travel faster than light. Yet here was an effect that appeared to do just that, to transmit information instantaneously, no matter the distance. Over the decades, however, as our understanding of quantum mechanics deepened, we've come to accept that quantum entanglement is real. In fact, it's been experimentally observed and verified, but don't worry, it doesn't actually violate the speed of light. The information isn't really traveling at all. It's just that the particles are so deeply linked. They behave as one, no matter their separation. So the next time you gaze up at the stars, remember, there's a lot more going on than meets the eye. Beneath the surface, at the quantum level, the universe is dancing to a different beat. It's a world where particles can be in multiple places at once, where the future can affect the past, and where, yes, spooky action at a distance is just part of the show. Quantum entanglement shows us that the universe is far more connected than we might think. In the quantum world, the more precisely you try to measure something, the less you know about something else. This is the uncertainty principle. Imagine trying to pin down a buzzing bee with a dart. The harder you try, the more elusive it becomes. That's quantum physics for you, and the uncertainty principle is its cornerstone. Introduced by Werner Heisenberg in the early 20th century, the uncertainty principle, also known as Heisenberg's uncertainty principle, states that the position and momentum of a particle cannot both be precisely measured at the same time. The more accurately we observe one, the less accurately we can know the other. It's like our dart and the bee. If we try to precisely pin down the bee's position, its speed, or in quantum terms, its momentum, becomes a blur. This principle is not due to any shortcomings in our measuring tools or errors in our calculations. It's an inherent element of the quantum world, a fundamental property of particles. This isn't a matter of simply not knowing enough yet. It's a limit that nature itself has set. The implications of the uncertainty principle are profound. It turns our classical understanding of the world on its head. It suggests that at the quantum level, reality is fuzzy. Particles exist in a state of flux, without definite positions or speeds until we measure them. It's a world that's less solid and more uncertain. The uncertainty principle also gives rise to the concept of quantum fluctuations, tiny random changes in energy that occur in empty space. These fluctuations are responsible for the creation and annihilation of particles and play a key role in the theory of quantum fields. In a nutshell, the uncertainty principle is a fundamental part of quantum mechanics, one that challenges our traditional understanding of how the universe works. It's a principle that keeps us on our toes, reminding us that the quantum world doesn't play by the same rules as the macroscopic world we're used to. The uncertainty principle keeps the quantum world shrouded in mystery. So, how does quantum mechanics fit into our understanding of reality? Quantum mechanics, this grand theory of the very small, is a real game changer. It challenges our conventional understanding of reality and forces us to confront a universe that's far stranger than we could have ever imagined. It's the world where particles can exist in two places at once, where cause and effect is not as straightforward, and where reality itself may be fundamentally probabilistic. Let's take a moment and think about superposition, a concept we've discussed earlier. In our everyday lives, things either are or they are not. But in the quantum world, things can be and not be at the same time until observed. This is a direct challenge to our intuitive understanding of reality. And then there's entanglement, a phenomenon Einstein famously called spooky action at a distance. Two particles can become entangled such that the state of one instantaneously affects the state of the other, no matter how far apart they are. This defies our conventional understanding of how information can travel, and it adds an extra layer of peculiarity to our quantum reality. What does this mean for us? Well, it's a question that's not only puzzled physicists, but has also caught the attention of philosophers. The philosophical implications of quantum mechanics are immense. It brings into question the nature of reality itself. Is the world around us truly as it appears, or is there a hidden quantum reality beneath the surface? Quantum mechanics even challenges the notion of objectivity. According to the Copenhagen interpretation, one of the most widely accepted interpretations of quantum mechanics, There's no objective quantum reality that exists independent of measurement or observation. This is a radical departure from our classical view of the world. But it's important to remember that while quantum mechanics challenges our understanding of reality, it doesn't necessarily invalidate our everyday experiences. The quantum world and the macroscopic world we live in seem to obey different sets of rules. And perhaps it's the tension between these two that makes the study of quantum mechanics so enchantingly complex. Quantum mechanics leaves us with more questions than answers when it comes to the nature of reality. Quantum mechanics isn't just theoretical, it's shaping our world today. This revolutionary branch of physics has moved far beyond the chalkboards of scientists and into the realm of practical application, becoming an integral part of our everyday lives. Let's start with quantum computing. Traditional computers, which use bits, can only process one piece of information at a time. Quantum computers, on the other hand, use quantum bits or qubits. These qubits can handle multiple pieces of information concurrently, thanks to the principles of superposition and entanglement. This means quantum computers have the potential to solve complex problems that would take traditional computers millions of years to crack. Companies like Google and IBM are already making headway in this field, pushing the boundaries of what's technologically possible. But the influence of quantum mechanics doesn't stop there. It's also playing a crucial role in our telecommunications. Quantum cryptography, for instance, is paving the way for ultra-secure communication. It uses the principles of quantum mechanics to encrypt data, making it nearly impossible to intercept without detection. This technology has far-reaching implications for fields such as cybersecurity, finance, and national defense. And let's not forget about quantum sensors. These devices, which leverage the properties of quantum mechanics, can detect the smallest changes in environmental conditions with unprecedented accuracy. They're being used to improve everything from medical imaging to navigation systems. It's clear that quantum mechanics is no longer just a subject of theoretical debate. It's a tangible, practical part of our world, influencing the technology we use and the way we live. It's providing us with tools to solve complex problems, secure our communications, and detect subtle changes in our environment. And as our understanding of the quantum world continues to grow, so too will its impact on our lives. The quantum world, though strange, is playing a big role in shaping our future. Let's recap the strange and fascinating journey we've taken into the quantum world. First, we dived headfirst into the concept of quantum leaps. We learned how particles can jump from one energy level to another without passing through the space in between, defying our everyday logic. It's as if you could teleport from your couch to your fridge to grab a snack without crossing the living room. It's a wild thought, isn't it? Next, we grappled with the idea of superposition, the principle that a quantum particle can exist in multiple states at once until observed. It's like Schrödinger's famous thought experiment where a cat inside a box is both alive and dead until we open the box to check. Superposition challenges our understanding of reality, suggesting that things are much more fluid than we might think. Then, we ventured into the realm of quantum entanglement, often referred to as the spooky action at a distance. It's the peculiar phenomenon where two particles become intertwined in such a way that the state of one instantly affects the state of the other, regardless of the distance between them. It's a form of cosmic connection that Einstein himself struggled to accept. We also delved into the uncertainty principle, Heisenberg's contribution that tells us we can never simultaneously know both the exact position and momentum of a particle. The more precisely we measure one, the less precisely we can know the other. It's a principle that reminds us of the limits of our knowledge and the fundamental unpredictability of the quantum world. Finally, we explored how quantum mechanics has revolutionized our understanding of reality and technology. From atomic clocks to quantum computers, the principles of the quantum world are reshaping our lives in ways we're only starting to comprehend. The quantum world is not just a realm of tiny particles, it's a vibrant, dynamic realm that's fundamentally intertwined with our macroscopic world. In conclusion, quantum mechanics defies our intuitive understanding of the world. It's strange, it's counterintuitive, and it's utterly fascinating. It pushes the boundaries of what we thought was possible and continues to inspire scientists and researchers around the globe. While quantum mechanics may be the physics of the very small, its implications are undeniably massive.